Hi, my name is Mark Winkelmann, and I would like to share with you 10 important skills you should cover in your teams when you want to build an analytical data platform. All right, let's get started with point number one. Before you even start, you should have a proper business understanding, of course, right? So before we dive into the technical part, what tools to use, what databases to use, you should make sure that your data engineers and the persons who built this data platform have a proper, or have at least to some extent, an understanding of the data itself, right? So they don't need to be honest, data analysts itself, right? Especially not for the technical part, but they need to know the structures of the data, right? So they need to know the different systems they use, what kind of data at least they can find there. And you should also know how to uniquely identify those and how they are related to each other with, let's say, a contract or an opportunity you have. The second part is to set a target, an objective you want to achieve with your data platform, right? So you don't build it because of you want to, or you have some fun to build something in the IT area. So there are some people in the background who spend money to this and they want to see a return of investment, right? So and that means you should take care that also the developers, right? So also the data engineers, that they know what they have to build, right? This not just brings them more quality into what they're built, that also increases the motivation of data engineers and also enforces them to think on their own, right? So to bring in their own ideas to also improve your end results. The third topic is have a proper data understanding a bit more in detail. So when you look into a source system, so this can look like really complex, right? So there are hundreds or not even thousands of tables. They are related to each other by using keys, primary keys and foreign keys. The people who are responsible for bringing the data from the source systems into your data platform should have a proper understanding how the data is related to each other. So what kind of business objects you have in which source systems, if they have a relationship with each other, like a customer has a contract, can the customer have more than one contract, or can he just have, or she just have one contract? So is there a one-to-one relationship, a one-to-many relationship, or even a many-to-many relationship? And all these things, in fact, the way of how you model your data later, right? And how you query the data later, and helps to better understand your data and make the whole process downstream much easier. The next topic is data acquisition. So you need some, let's say, more technical people who know how to get the data from the source systems. Can they call an API, for example, or do we get daily CSV files or JSON files or whatever, right? So they need to know how to get the data out of the source systems to bring it into the data platform. Also, what kind of data do we get? So do we get a full extract every day? So this also needs to be handled a little bit differently compared to when we get just the changes from the last time where we got data. So this is what we call change data capture, CDC. Also, this reduces the amount of data you have to handle, but also you need to know how to handle it. And that's why this is also a very important skill you should cover in your teams, that you have people who are able to get the data out of the systems and provide it to you, or provide it to the other teams which are generating then the value out of that data. So now we can talk about an architecture. So because you should not just dump your data somehow into your database technology, you should do it with a structure. So what I like to prefer is the medallion architecture. So where you have basically 3 layers: a bronze layer, a silver layer, and the gold layer, with different purposes. The bronze layer is therefore stage your data, or to be honest, it has different names in the industry. It's called the staging layer. It's also called the landing zone, or it's even called the data lake if we talk about the file system. But this is the first place where your data lands, but nothing really special happens with the data. The real transformations on modeling and integrating the data across multiple systems, harmonizing your data. So this happens in the silver layer. So in the silver layer, you apply a modeling technique, you cleanse your data, you prepare the data for data consumption, and this is the third layer in your architecture, the gold layer. So this is a layer which is user-friendly, where people without deep technical knowledge have the chance to also query that data with front-end BI tools, whatever it is, and to get good insights into your data across multiple systems and having a very good quality there. Now we have a nice architecture in place. And I already talked about the bronze layer and the gold layer. And the most magic, in my opinion, happens in the middle and the silver layer, because this is the point where you integrate the data across multiple systems. And this is where we need a proper modeling approach. So here we need to unify your data across multiple systems. So that's why you should select a industry-proven modeling technique. So this could be, for example, the third normal form. This could be a star schema, or what I like to prefer when you target an enterprise data platform across a lot of systems, I like to use the data vault approach. The data vault approach is a very scalable and highly automatable approach to build basically your whole data platform. Next topic is temporality of your data. So you usually don't have just one timestamp or one timeline in your data. You usually have multiple ones. You have technical timelines, like when we extracted the data from the source, when did we load it to the data platform, when it got last updated. But you also get some business timelines, like when does a contract start, when was the sign up from this customer, when does the contract end for this customer. So you have usually multiple timelines, and you should have a strategy on how to deal with that. So how to get out the most recent data, for example. Is it based on more technical perspective? Should it be more on the business date perspective? Do you want to create snapshots, for example? And if you go for creating snapshots to also compare reports, like the report from last week with the report from this week or from last month or the last quarter, you should also think about on which dates or on which columns, which timestamps you create those to make it also comparable. And also thinking on auditability. So what about backdated data? So what if I get data right now, technically, but which has an effective date of last month, for example? Doing everything by hand is what I can really not recommend. So that's why you should have a look into some tools which can help you to automate as much code as possible, and especially to generate you the code and automate the orchestration of loading the data from one layer in your architecture to the next one, to the next one. So there are a couple of tools in place which are helping you to generate a lot of code so that your engineers basically, or your business users, can spend the most of the time at that point where you generate business value, right? So you don't want to have a lot of data engineers which just take care of loading the raw data from point A to point B. This can be automated, this can be generated. So there's no need for writing hand-coded Python code or SQL code, wherever, right? So there are tools for that which knows all these patterns also related to the modeling techniques, whether you use a star schema, a third normal form, or even data vault, right? So there are tons of tools which can generate you all the code. You don't want to have this delay, first of all, right? So because if you do it manually, it takes much more time. And the same point is the quality is usually better because everything is standardized, everything is put into templates or into patterns. So there's no space, let's say, for too many human errors. And so the return of investment comes much quicker. So we usually prefer using an agile way of working. So that means we want to produce small pieces of working software in very short iterations. And this also works really well related to the architecture I talked about, like bronze to silver, gold. So what I like to call it a traceability approach, that you take a target. So you want to, for example, create the revenue reporting, the monthly revenue reporting. So you trace back to the source system. So what data you need to fulfill the objective. So that it's again, that the data platform project doesn't become a technical project. So where we say, hey, let's take all the data we can get from the source systems and bring it to a data platform. The source systems usually have tons of data, right? So they have thousands of tables. And if you spend effort in bringing all these thousands of tables into the database, when you look then at the end, how many of these tables are effectively used, that's usually not that much, right? Or not that many tables. So that's why you should always focus on really what you need. You know the target, traceability approach, just select the tables or the data you need from the source system and only focus on that one and only model that one through this medallion architecture. Only stage them into the bronze layer, model them into the silver layer, and provide the data in the gold layer. The last point is automation. Now we have everything in place. You have skilled people who know how to get the data from the source. You have skilled people who know how to build up a proper architecture. You have people now who have a proper modeling in place, and you have people who know how to present the data to the end user. So you have now everything what's necessary to build an end-to-end solution from the source data to the point where the business value sits or where you can harvest your work. So the next step is to automate everything that it runs like an old machine, right? So that as soon as you have new data, that it's pushed to the data platform, that no one has to click a button every day to get the new data, that tests are running automatically, that you don't get surprised of bad data quality in the code layer, for example, and so on, right? So, and here we're talking about DevOps. So you should have some people with DevOps skills who know how to orchestrate data loads, how to orchestrate the data loading from the sources into the first layer, into the bronze layer, how to orchestrate the data from the bronze layer into the silver layer, and also how to produce the gold layer. It could be also, for example, completely virtualized, right? So, or you, from performance perspective, you maybe also materialize, but there are also virtualization strategies, performance aspects, and because you're in the cloud, also someone who needs to take care of your costs. Jobs you run usually on premise, which run for hours, this is something which gets really expensive if you do that in the cloud. So this also enforces you to monitor your costs and also to find the bottlenecks or to find the pain points in your data pipelines where you should have a look into and where you have to do performance tuning and cost reduction. These were 10 points you should cover in your teams, and if you have all those to some extent, I'm pretty sure you will have a successful project for building your next analytical data platform. Thank you for watching. If you want to build a scalable and resilient data platform, read the free Data Vault Handbook by scanning the QR code or accessing the link. Bye and see you soon.